Hello, my name is Muhammad Hazim Bisri,
My metric number is 78248.
and I want to explain about this experiment. So, we see this schematic diagram first. This is a schematic diagram of the experiment. We have 1.5 volt of battery. We have three resistor. This resistor 1, 2, and 3. Resistor 1 is connected in series. Resistor 2 and 3 is connected in parallel. Next. Uh, as we know, this is a theoretical value. R1 equal to R2 equal to R3. This is all of the resistor is 1 kilo ohm. Next, we have to find R total resistance in this circuit. So R2 and R3 are connected in parallel. So we find R2 and 3 first. 1 times 1 over 1 plus 1 equal to 0.5 kilo ohm. So R2 and R3 is R23 is 0.5 kilo ohm. So we have to find R total R, that is R1 to 3. So R1 is series with R23 that has been plus. So R23 plus R1 where 0.5 kilo ohm plus 1 kilo ohm. So the total R is 1.5 kilo ohm. Next, we calculate the total current using Ohm's law formula. V equals to IR. Total V, we have this instead, 1.5 volt. So total R that we want to find, and total R we have find before 1.5 kilo ohm. So we substitute into the formula, we get total I, which is 1 milliampere. I total is equal to I1 because I total is flow through I resistor R1. So the total of current and I1 is equal. Since R2 resistor R2 is equal to R3 and in parallel, the current R2 I2 and I3 is the same. So we find the I2, I equal over 1 over 1 plus 1 equals to 0.5 milliampere. So the current I2 and I3 is 0.5 milliampere. This I2 and I3 0.5. Next, we find the total voltage at V1 first. V1. I use formula of voltage divider rule, that is 1 over 1 plus 0.5 times total voltage, that is 1.5. So we get V1 equal to 1 volt. V2 and V3 is equal. Voltage is equal because V2 and V3 are in parallel. So in parallel, voltage are equal. So we find 0.5 over 0.5 plus 1, and we get 0.5 volt. So for V total, 1 V1 plus 0.5 equal to 1.5 volt. So this is the table. So current theoretical at point BC. So BC, current at EF at R2, HI, current at HI 0.5. So current at JK, total current, this circuit, JK. So partial voltage at test point AB, voltage must calculate in parallel, this AB. So at point DE is equal to 0.5 volt, DE. Point GH is 0.5 volt, and total voltage AK. I'm sorry, this is 1.5. Before I construct circuit, I will check the actual value of voltage and resistor first. This is 1.5 volt battery. We'll turn to voltage. .63 volt. Okay, next I will check the first resistor. Turn to ohm first. This is 1 kilo ohm resistor. .975. Okay, next resistor. .966. For the third resistor. .964. Okay, I use jumper wire to connect the circuit. So this is my circuit look like. Now I will check the value of voltage in this circuit at point A and K. Change the voltage first. .608. Next, I will check the voltage at resistor 1 at point A and B. A and B. So 1.04. 1.04. And now the second resistor, I will check at point D and E. D and E. Zero point 0.53. Next, the third resistor at point G and H. G and H. Also 0.53. Okay, now I will check the total current at the first resistor. First, I will check at point B and C. You must disconnect first because I want to measure the current in series. .07. For the second resistor at point E and F. E and F. Zero point 0.53. 0.53. And the third resistor at point H and J. H and J. Disconnect this. Also 0.53. Next, I will check the current of the circuit at point J and K. This point, 1.08. 1.08. From this table, the measured partial current at test point E, F and HI were 0.53 milliampere, while its theoretical value was 0.5 milliampere. For the total current measured value, both test point B, C and JK were 1.07 milliampere and 1.08 milliampere, while its theoretical value was 1 milliampere. The main reason why measured data in table was higher than theoretical data is because of power supply from the battery. 1.5 volt dry cell was 1.60 volt. This is higher than the theoretical value. The second factor that gave high measured data to this experiment was the value of the resistor that I used a little bit lower than the theoretical resistance. And the last factor that affected the measured data was resistance in wire. The difference in measured and theoretical value occurs due to the amount of resistance the current need to pass through before getting into the multimeter reading, which the contribute was the wire. Even though both measured and theoretical value for partial current and total current were different, the difference was not too significant, so the measured value can be accepted. The measured and theoretical data for partial voltage have a different value. At test point AB, the measured value was 1.04 volt,
and the theoretical was 1 volt. For both test point D, E and GH was 0.53 volt, and the theoretical value was 0.5 volt. And last but not least, the total voltage for measured was 1.6 volt, and the theoretical value at test point AK was 1.5 volt. To explain the difference in value between measured and theoretical value, the definition of voltage need to be defined. Voltage is an electromotive force or potential difference expressed in volt. This was due to wire using the electromotive force energy dissipated in form of heat energy and reducing the accuracy of the reading. The longer the wire the connection, the higher energy for electromotive force will dissipate to the surrounding in form of heat energy. In conclusion, a circuit has been constructed using a 1.5 volt DC battery, breadboard, wire and 3 1 kilo ohm resistor. This can make students know how to use multimeter and how to construct a circuit and how to measure partial current, partial voltage and total current in the circuit. The measured partial current at test point is very important because we can use in the next time.